Hi guys, welcome back to another video. Yesterday we looked at orbitals and how we write them. So we saw this, we saw the answers to this, but also we saw what the shapes of the orbitals look like. So just a reminder, this is our 1s orbital, it's written like this. This is our p orbitals, they're written like this, so they can have 6 electrons total. Each of these p orbitals can have 2 each. 2 times 3 equals 6, and they look like dumbbells. Our d orbitals can have 10, because there's 5 of them, and they look like this. And so it's written like 3d10. And we also ended with this. We fill up our orbitals like this with 1 electron. So 1s can hold 2 electrons, and our electrons are written like arrows. So 1s and 2s can hold 2 electrons each, and each arrow represents 1 electron. When we get to 2p, we can start singly filling up our electrons, our orbitals, before we double them up. So we singly fill them up before we double them up, okay? So it's not written like this, so this has got 1, 2, 3, 4, 5, 6, 7 electrons. 7 electrons, of course, is nitrogen, element number 7. So this will be nitrogen's electron configuration, and it's not this. And this is an energy level diagram, okay? So we fill up our 1s first, because it's the lowest energy. As you can see, energy increases as we go up. We don't have to worry about these higher ones, we're just going to stop it like here. 1s gets filled up first, then 2s. The next lowest energy is 2p. Then it's 3s, 3p. And then 4s and 3d are very similar in energy. We fill up our 4s first, before we fill up our 3d. Okay? We'll get back to this later on. I'm going to put this video in the Google Classroom for you to have a look at. And please do not let this be you. You should understand orbitals. They're not too tricky. So we can get there. So, notes for your book. We always fill up 4s before we fill up 3d. If you could just note that down so you remember it. We fill up 4s before 3d because it's slightly lower in energy. Okay? As you can see here, our 4s orbital is slightly lower in energy than the 3d orbitals. So, electron configuration jumps to the 4s orbital, and it wasn't very cash money. There's lots of memes made about this because it doesn't really make sense, but 3d gets skipped, except for 2 elements, and we'll have a look at why those 2 elements get skipped. So if you could note this down, 3d gets skipped, except for copper and chromium. Okay, so electrons go to the 4s, and they skip 3d, except for copper and chromium. Okay, and while we're on that subject, just note these down really quickly as well. Exceptions to copper and chromium. Chromium, if an electron is moved from the 4s to the 3d sublevel, the 3d sublevel is now half filled. Okay, so we're going to take a look at this and see what this means. So this is chromium's electron configuration. Most importantly, it's 4s1, 3d5. So let's take a look at what that looks like. Here, I've set up an orbital diagram, and how we fill this up is, I'll change color to red. We can just fill it up like this. So we normally go 1 here, what's 1 electron, 1 there, that's another electron. And we're going to keep filling these up. We're going to go like this, this. We singly fill up this because electrons prefer this, it's lower in energy. So this will be nitrogen. When we go to oxygen, we add another electron. We go to fluorine, we add another. And we go to neon, and we double up. Okay? That's our configuration for neon. We go to sodium. We go to magnesium, aluminium, silicon, phosphorus, etc. So we fill this all up. And this will be our argon. Okay? So we go like that. And then we get up to here. We can go to our potassium. We can go to our calcium. And then we start filling this up like this. This will be our, what would this be? I can pick, it's scandium, I think, then something else, then vanadium. But the point is we fill this up until we get to here. And this is chromium, if we're looking at just the normal way we'd fill it up. However, what chromium does is it takes this electron that's in the 4s, says I don't want that one there, and I'm going to put it here because this is lower in energy. Okay? This is lower in energy, so chromium is going to be weird, and it's going to do this. The only reason why it does this is because singly occupying all of these 3D orbitals is lower in energy. That's the only reason it does it. It's more stable this way. Fair enough. So chromium does this. What does copper do? Well, let's go back there. And then we keep filling this up. And we get to copper. This should be copper, okay? So this should be copper now. However, copper again does something weird, and it says, I don't like this. I am lower in energy if I completely fill up my 3D shell and get rid of this one electron here, okay? This is what copper does. So it completely fills up its 3D shell, and it has one electron in its 4s, again because it's lower in energy. So copper and chromium are the weird ones. They're the two exceptions to the rule of not filling up the 4s completely first, and then it does this. Okay? So, let's get back to here. Chromium. If an electron is moved from the 4s to the 3D subshell, or sublevel, the 3D sublevel is now half filled. So we saw that happening here. We saw it with our chromium. If it moved one electron from here to here, it is now half filled, and that is stable. So that's what chromium does. If you can note that down in your books. This configuration has added stability, which means it's more stable, which more than compensates for the energy needed to move the electron from 4s to 3D. So this is the electron configuration for chromium, and it's a very common exam question. Notice our 4s subshell is only half filled with one electron there, and our 3D is half filled as well. This gives it extra stability. So if you can note this down for chromium, and also note down the electron configuration for chromium. Next we have copper. When an electron is moved from the 4s to the 3D subshell, the 3D level is completely filled. The filled 3D sublevel also has an added stability, which means it's more stable, which compensates for the energy needed to move the electron from 4s to the higher energy 3D. So this is the copper electron configuration. Please note this down as well. Notice it's 4s1 and 3d10. Very important that you can know this, and that you just know it's more stable. Most importantly is you know the configuration. These are the only two exceptions of normally we fill up 4s before 3D. Copper and chromium are the only two exceptions, which is why there's a lot of memes made about them. Like this. The after principle is building up, so we fill lower energy first, and then copper and chromium screams because they don't like it. They fill up their 3D first, like this. Chromium's half filled and copper is completely filled. Again, another fantastic meme. When copper's 29th electron goes from the 4s to the 3D orbital. Fun fact, I was watching this Bob Ross episode, doing the painting, and this came up, and I was not expecting it, and it was a great moment. Fantastic. So remember, these are our d orbitals, and the only reason I have this slide is for the fantastic meme that comes along with it, which is this. When she says she's only into d z2 orbitals, which DZ2 is our name for this orbital here. You don't need to know any of these names. If you do like second year uni chemistry, you might need to know them. And last meme for the video, for electron. If an electron in the p orbital wore pants, would it wear that like this or this? I'm gonna go with this one. These pants seem to not fit very well. Okay. Tomorrow we're going to look at the electron configuration for ions, but we won't get to that just yet, and I'm ending the video now. Have a good day, guys.